Hey folks, welcome out there. How are we doing today? It is middle of the week, you know it, and it's Mathline time. Thank you for tuning in. We're so glad to have you with us this afternoon. I'm Ernie Roberts, and I am your host for the afternoon session of Mathline. So many of you tune in. Some of you are checking us out on Facebook, getting some problem of the day results. Some of you need to be going there, all right, and checking us out. Also, hit us on those Twitters and Instagrams, other good places. We want to hear from you, okay? Give us some questions, email us, whatever you want to do. But right now, we're going to get you on the phone, and we want you to call that number, 844-686-2378. That's your ticket into Mathline today. We'll talk one-on-one, solve the problem together, and hopefully be a win-win for both of us, all right? In the meantime, let's get warmed up with the problem of the day while you guys are checking in with us. And our problem of the day, evaluate the expression absolute value of x minus, oh my goodness, there's all sorts of stuff here, minus the parenthesis with a y minus z inside of that. And notice those vertical bars mean absolute value. So what we're going to need to do is think about what is absolute value when we get the final answer. Now we're giving some values for x. X is going to be -8. Y is going to equal 6, and Z will give us a -5 also. So lots of minuses and lots of negatives, and what do we do with them all? All right, well, let's find out. Let's take a look at this thing and see where we're going to go. First of all, evaluate simply means we want to replace these variables with numbers. So many of you will tell me, oh, Ernie, I liked math until they started putting those variables and did the algebra stuff with it. Just remember, these variables have to stand for some sort of a number, all right? Sometimes you're given that number. Sometimes you're looking for that number. You're trying to figure out what is that number that's going to make this a true statement. Well, here, we're given all three of them. We're going to stick them in there, and we're going to figure out what's going on with it. Now, some of you who tried on Facebook, we got some answers of 19 or -19. That seemed to be the popular suggestions. There were some of both, all right? And we'll talk about that in a minute. I don't know which one of you got it right, but I've heard from Margie, Mark, Sandra, Vicky, and Jason today. And we're going to see what happens, all right? So let's go with it. Let's go ahead and write that problem down at home if you haven't had a chance to look at it. Put it in there. And we'll put subtracting y minus z, and then this big bar. So you didn't miss any detail, right? The variable x minus whatever y is, subtract z, but notice what we got to do. We got to do these parentheses first. So the very first thing before we go anywhere on this, let's do some substitution. Let's replace these variables, these hated letters, with those lovely numbers, all right? So here's what we got. We've got a -8 popping in for x. Everybody good on that? We're going to subtract the y. Well, what was y? Y was 6. But we're not going to subtract just 6. We've got to wait a minute. All right, we've got to work inside this parenthesis, which says we're going to also subtract a -5. Now, sometimes people like to put a parenthesis around it. That's fine. That's fine. But we will understand this is subtract, and we're trying to subtract a negative, which means we're going to do a little trick with that. Go ahead and close the parenthesis and put the bars there. Now, notice, parenthesis goes first. Well, this gets a little bit beyond my dear Aunt Sally, doesn't it? Everybody's going, whoa, what order do we go in? Well, at the end, it's basically we have big brackets, but they aren't brackets, they're absolute value bars, so we've got to do a special thing at the end. So inside, let's work here first, all right? So remember I said, when you subtract a -5, it's like adding a +5. We're going to change those signs. It's going to be add the opposite. So let's rewrite where we are, and we're going to keep -8, haven't messed with it yet. Now, what do we have? We have an 11. Not a -11, but we have -8 minus 11, all right? Now, where we're going to go from here, we're going to deal with the fact that we got two negatives going here, basically, even though I said subtract, I know. But remember, it's like saying plus a negative right there. So we're going to look at it as being a -8 and a -11. We're going to add them together, and we are going to come up with -19. Which was one of the solutions some of our callers and some of our writers on Facebook gave us. But here's the catcher. We got to know what the absolute value is. Now, what is absolute value? It is how far away a number is from 0. So what this is telling me, if I were looking on the number line, where would I find -19? I'd find it to the left, and it would be the left of 0. How many blocks away from 0 is this? It's 19. And we're going to keep it that way because distance is always positive when we're looking at that. So when we talk about absolute value, 19 is our final answer there. So you guys, hopefully you got it home. So hopefully you got when we work through this thing. Watch your signs. So, so important. And in the end, remember, what is absolute value all about? It's about changing. Well, is it changing? If it's negative, it's changed to a positive. But if that had been a positive 19, it would also be 19. It's basically how far away from 0 is our final answer when we have those bars like that. So there you go, absolute value, a little bit of adding and subtracting remembrance with positives and negatives, and a good start to our show today. Now, it's your turn. Give some calls, all right? 844-686-2378. We are looking forward to hearing from you and your problems today. Math problems, obviously, we're not wanting to solve everybody's personal problems or stuff like that. All of a sudden you say, you know, my math problem sometimes is a personal problem, Ernie. But we do want to hear from you guys, so give us some calls, all right? We got operators waiting to take care of you today, and I'm ready to take care of you also, okay? Live here on the air, we will work the problems out together and get you some, hopefully, some good, positive, and maybe negative answers even, but good answers for your solutions, okay? Now, let's take a look of speaking of a problem that has a solution. Yesterday, you remember we had a problem of the day that didn't have a solution per se. It was an impossible situation, and what we'd gotten set up with, well, you know, we had to work around it, and some of you caught on to that very wisely. But in the meantime, like I said, give us that call, 844-686-2378. Hopefully, those of you at home watching us or online watching us, taking care of writing this little problem down. We've got 5x minus 45. Just a good little algebra thing. We haven't done really just good old algebra much on the show lately this season, so we're going to throw one at you here, all right? Equaling to x minus 21. And we're going to check the solution. You say, Ernie, what does that mean? It means whatever we get for x, you remember what I said earlier in the problem of the day, some of you are going like, oh, this time we have to figure out what x equals. Yes, we're not going to give you the x, but we will check it once we find out and see that it's going to work, all right? So here's the story. I got 5x minus 45 on the left-hand side. I've got x minus 21 on the right-hand side. We want to balance. We want to come up with the same amount given a specific x that's going to make this work, all right? So it's kind of like looking for the piece of the puzzle that's going to make this all fit and make us all happy. So let's do it. Let's subtract the x. Right there we go. And, ooh, that good old subtraction property says if we do it to the right side, we're going to have to do it to the left side. So right, left, right, left. You got to remember, keep going equals here. That's what the equality properties tell us to do. So this is subtraction. And let's do it right over here. Let's subtract x. And let's see where that takes us. Takes us to 4x minus 45. And on this side over here, we got it equaling to a negative 21. Now, my friends, what we got going on here? We're trying to find this value, remember, of x is going to make a true statement. So we need to get x by itself. That's the goal. So all of a sudden, we've gotten the x's together, some like terms going on here, although we had to move them across the equals mark to get them to work together. But now we got like terms that work right here. And these, of course, just cancel out. That's why we chose those. Now, where are we going to go from here? We are also going to move this 45 to join it up with the 21. Now, very careful, algebra students, adults, young folks, everybody who's watching today. Don't just say, oh, I've got a negative 45 and a negative 21. That gives me a negative what, 66? No, it doesn't work that way. Doesn't work that way. We've got to add 45 because, see, we want that to disappear. We want that to become a 0, so to speak. So you've got a minus, subtract, however you want to look at it. You've got to call it a negative if you want. You've got to put a positive to it, all right, to add. So we're going to do that. And again, we're going to play the same game right over here. And that's going to leave us with 24. Now you say, Ernie, how did you do that? We had a negative 21, a positive 45, and the signs are different. So we need to subtract in this case. So one's positive, one's negative. Subtract the two values. You will get 24. On the left-hand side, we're still hanging on with 4x. Now, I want to go back and remind everybody also a little bit. Yeah, Ernie just likes to remind people a lot of things, doesn't he? So over here, when we did have 5x and we subtracted x, that wasn't meaning that the x is left. That meant we took away 1x, and that's how we got 4 of those. So remember, it's like having 5 x's in my hand. I take away 1. I have 4. There we go. 4 back in the camera there. So at this point, let's see if we can wrap this one off and see where we're going to go with it. It says 4 times the number gives us 24. What's the deal? How do we figure out the number? We got to divide. 4 times what number? So we're going to divide the 4 to both sides here. And this is one of those, a lot of times we don't necessarily put the 4 underneath both of them, but I want to show you what's going on. We are dividing both sides by 4, and that's going to give us finally x equaling to 6. Now, as say, be careful, watch your signs as you go through here. Now, the question is, do they work? Check our solution. So we have got a solution. It says x equals 6. I hope it's going to work. Let's find out. We got 5x. Go back to the original problem. Don't jump in the middle. Go all the way back to the beginning. So we got 5x minus 45 equaling x minus 21. And put your 6 in the place. And I'm going to put the 6's right above there. All right, and we'll put a little circle around them so we don't get them confused. 6 going in for x right there. And we have 30 minus 45. Over here we have 6 minus 21. Now the idea is we want both of these to equal the same value. When we take 30 minus 45, remember that's just like saying, 30 and you subtract 45 means you're going to be in the hole. You're going to be at a negative, and you're in the hole by 15. It's also like just saying 30 plus a negative 45, which gives you negative 15. Over here, what do we have? We have 6, again, plus a negative 21, or 6 take you 21 in the hole. Either way you stack it, you're going to be at a negative 15. That is your check. Not that you come back with a 6. The 6 is what we started with. This time we want to come up with just basically, we got to have the same number here. And negative 15 is where that one ended up. So there's your check. Tells me it's a good solution. And there's probably a little problem, a little equation. So those of you who are in the pre-algebra and algebra 1 classes right now, you're getting into those kind of things pretty soon. I know how it works there. So there's your good example to help refresh that memory and get it going again. Now, let's get those numbers going here, right? As I say, 844-686-2378. We want to hear from you. We want to solve some math problems live here on the air. So far, no calls have come through, but, we know it's a good another 15, 20 minutes of Mathline. So we are going to look forward to hearing from you guys as soon as you possibly can. In the meantime, I think we have a Hey Mathline waiting for us. Guys, is that correct? We check it out? See what we got there. Here.
Hi Mathline, I'm Addison and I attend Bearden High in Knoxville, Tennessee. What is the simplified form of the expression 5x to the third, y to the fourth, z to the negative third, times negative 2x, y to the negative 6, z to the third with no negative exponents?
Ooh, okay, so we're going to simplify the expression, and that's a major expression, folks, especially when we had to use those little, and that was that little caret means raised to the power. So 5x to the third power, y fourth, z to the negative 3. They're all jammed together inside one parenthesis. There's no pluses or minuses there, so don't get excited. Now in the next parenthesis, we've got a negative 2x, and since it's a negative, since it's at the front, y to the negative 6 power. Whoo, that's crazy. And z to the third. And Addison has said, from Bearden High School here, has said no negative exponents allowed in the final answer. Okay, we'll do that. Just for you, Addison. All right. So let's take a look at how this thing comes together and how it works. So we got to simplify the expression. Got it. Means we're going to basically combine all this into one nice lump. Those of you who want to know what x equals, not going to happen today. All right. Not on this one anyway. Not on this watch. This one we're just going to try to get them all together. How many x's, how many y's, how many z's, and then what kind of number on the coefficient clump at the beginning. Whew, a lot of stuff to do. Let's take it one step at a time. All right, so it's a multiplication problem, which first of all, let's talk coefficients here. We got a 5, we got a negative 2. And again, that is not a subtract. All right, it's not a subtraction there. This is all in parentheses, so it's multiplication all the way through. So let's check it out. 5 times your negative 2 is going to give you, a negative 10. Now, we don't have to worry about the 5 nor the negative 2 anymore. Those are finished for us, all right? That's done. Answer negative 10, that's fine. Remember we said no negative exponents. We can have negative coefficients. We can have negative numbers at the front of the puzzle. So let's see what happens next. We've got x to the third and we've got an x. Now first of all, the question is very, very straightforward here. Are we going to say 3 times 1? Is that what we do with those exponents? It's a multiplication problem, isn't it? Or do we say 3 plus 1. And some of you are going, where's the 1? I don't see a 1. I'll put 1 there for you, okay? We've got a 1 right there in case you need it, all right? So we're going to do 3, I believe we're going to go plus 1 on this, right? Because when the bases are the same, you add your exponents. So 3 plus 1, that's going to bump it up to x to the 4th. No negative exponent there, so we're happy. We like that. Let's take a look at our next one here. The y values here. Y to the 4th, y to the negative 6. Group those together. So we're just going to focus on them. Again, we didn't multiply the exponents with 3 and 1. We're not going to do the same thing here. We're going to go back to adding those, just like we did with the 3 and the 1 here. We added them to get 4. So let's take 4 plus negative 6, and you know what? That's going to give us a y with a negative 2. Now, the hardest thing about this is if you don't know the difference between the 3 different letters. That's all you have to do is look, matching up your letters. Match up your variables here, okay, together. That's all it takes, all it takes. So let's see what happens on z. We've got z to the negative 3. Well, you know what we're going to do now with these two things. We're going to add, right? Everybody's going to do that. We're going to add your exponents together, of course. And what's going to happen is we're going to get a z to the 0 power. So what do you do with that, Ernie? We'll talk about it here in just a second, all right? It's not negative, but it's not positive either. But it does have a special situation. Basically, it means that we have no z's here. Well, z to the 1 was z. So z to the 0 is going to give us 1. Just go with me on that, all right? Not an exponent of 1, just 1. And multiply it with negative 10, you just get negative 10. So basically, say goodbye to z to the 0. It just gives us a 1 we're multiplying with, all right? If that had been a plus or minus between all that, well, it would be a different story. But since we are just at that point, it's multiplied, it's absorbed in, we're good. Now, the next part here, remember I said negative 10, x to the 4th. Those look good. Those are fine. Question is, what are we going to do with this thing? We got this y to the negative 2 power. And Addison said it can't have any negative exponents in the final answer. Well, that's certainly a negative exponent. So here's where we play this game. We make a reciprocal situation. You say a reciprocal situation? Now we're going to make this 1 over y squared, which means we're going to keep this part in a numerator and send this part to the denominator. And that, folks, is going to be where we end up. That's our simplified form with, as he said, no negative exponents in the final answer. So Addison, there you go. Real quick recap on this while we're waiting for some calls. Multiply the big numbers. Multiply those coefficients, we call them, all right? 5 and the negative 2, there you have it. The next step is what do we do with the exponents? Because we've got some x's. We're going to add them together, the exponents, which is basically saying we've got x to the 3rd. Let me just kind of scribble it out over here. And we're going to bring another one in there times x. Well, it looks to me like we got x times x times x times x. That's how we get x to the 4th. Simply add your exponents. So this would be like taking x to the 3rd times x, which equals x to the 3 plus 1. So there's your story on that one. That's where we go there. Same story with y to the 4th and y to the negative 6. We're going to go back. We're not going to write all those out. We don't really want to, right? You're sort of, I agree, Ernie. We don't want to write all those x's and y's in this case. And a lot of things going on. So that's where we end up with y to the negative 2 power, which is a bad news according to Addison and according to what we do in our math world. We don't like negative exponents in our final simplified form. So just get ready. You got to move them. The z to the 0 gives us 1. That's nice. Any number to the 0 power will give us 1, all right? And how does that function then? So say goodbye to the z. Negative 10x to the 4th stays on top in the numerator. Y squared goes to the denominator. And now we have a happy ending. So Addison, good question. And I know many of you are getting to that point in your algebra classes and your pre-algebra and your 7th and 8th grade math classes. You are learning how to deal with these exponents and these exponent rules. So just keep them straight. It's kind of funny because you're multiplying, and when you're multiplying monomials, which we call these creatures monomials together, it's funny because you're actually adding exponents, but you are multiplying the big coefficients at the front. So go with it, and in this case it is negative 10 times x to the 4th, and then we're dividing by y squared. So keep it straight, keep where it goes, and life will be good to you on those things. All right, so speaking of being good, let's hear from some phone calls. We would love to hear from you folks today. It would be nice. Wouldn't it be nice to have a call or two here to finish off the show? Now, let's do a little more simplifying. We've talked about the algebra look with exponents. This time we're going to lose the exponents. We're just going to keep some x's here. But let's play through these. We get a call, we can break away from these. If we don't, we'll try to finish these out. If we don't finish them out, we'll get them on another day too. So, what's the story here? It's called the distributive property. Big deal here. Yes, sirree. And one of the big deals is knowing when are you distributing and when are you not. And teacher sometimes says, well, when you see parentheses, you got to distribute. Well, that's partly true. And they probably said more than that. But what goes on is, if there's a plus or minus inside that parenthesis, then you can distribute, okay? So you say, Ernie, I'm looking. Yes, 1, 2, 3 of them have a minus sign. This one does not. That's a -4, there's no, in other words, the parenthesis does not have any something plus or something minus. So you get the idea? So on this one, what are we going to do? To simplify, we're not trying to find out what x equals here. That's not the point. That's not the problem. But what we are going to do here is say, distribute. We're going to take 4 times your 3x, 4 times your -5, and we're going to end up with 12x, because that's what happens when you multiply. 4 times 3, bring the x for the ride, and go 4 times -5, we're going to have a -20. Now I have some of you ready to jump in and say, oh, I get it. So now you get -8x. No, you don't. No, you don't. These are not, I repeat, not like terms, so you can't combine them. You have to leave them as they are. Now, if I give you a value for x, you can finish the problem, okay? You can simplify it even more. But since we don't know what x is, and we're going to leave it open, kind of like a little rule, yeah. So every time we multiply by a number times 12, and that was saying, any number we multiply by 12, we're going to do what? Subtract 20. So in this case, it's the plan, but all we got to do is leave the rule, and we'll let someone else come along and do some numbers with it, and other good things. Now, what about our next little problem set up over here? We have a -6 hanging outside. It's still the same story. It's a distributive property moment because there is a minus between 5x and 9, all right? So let us do this. Let us distribute. Slide that -6 through there and see what we get. I'm getting a -6 times 5x, which gives me -30x. And what happens, watch closely. We take a -6 times a -9. And two negatives, when they multiply together, they do come out with a positive. And by the way, 6 times 9, some of you got that, most of you got that, all of you got it? I'm going 54, all right? And again, notice the signs basically change from the parenthesis down here to the final answer. Watch your signs, be very careful. Now, remember I said, two of these two are definitely distributive property situations. We have one that does not follow the rule. Now, if I had put it, see how I did this? If I had put 40 minus 4 in that same form over here, then we'd have a distributive property rule, but we'd have the same problem actually, okay? This is different than this one. On this one, it basically is sort of like what we did with the exponents on Addison's problem just a minute ago. We have the -5, the 40, and the -4, which we're going to multiply all together. And we'll bring the x along for the ride at the end. So let's see if we can get the multiplication right. We got a negative times a negative. It's going to go positive. And did I just do that negative times negative? You said, Ernie, can you jump around like that? I certainly can. It's called commutative property, all right? So I've got a 20. Basically, I got 20x. And I've got a 40. I'll put a little parenthesis around that so we know we're going to multiply. And let's go 20 times 40. I think we're going to get 800. And we're going to get 800x. Now, that one did simplify to simple monomial, simple one term there. All right, everybody good on that? Slide it up just a little bit. Now, how about our final one over here? Got a parenthesis waiting for you. We're going to distribute. And some of you are going, Ernie, could you go ahead and said 40 minus, what is that? 4? Get 36 maybe? Well, that could be, but you know, I think these are easier to multiply with a 5 out there and a 40 and a 4. So I'm going to go with it. And we're going to get, and by the way, it is a distributive property moment because there's a subtract there, isn't it? So let's do it. Let's get a negative, what, 200x. And let's get a plus 20x, because we're going to run the 5x. That's not a time symbol. That's just 5x. We're multiplying the negative 5, the x, and the number we get inside the parenthesis. And oh my goodness, we've got like terms this time. So let's put them together, get a negative 180x. So you say, well, Ernie, could we have done it? 40 minus 4 and gotten 36 times negative 5x? Absolutely. It would still give you 180x, and it would be on the negative side of that. It would be negative 180x. So there you go. A little bit of when you distribute and when you don't. All right? And there you have it. Mathline finishing for today. Thank you for tuning in. Thank you for being with us this afternoon. We appreciate you. Thank you for checking us out on Facebook. Be sure to like us, love us, and share us. And you know what? We're going to see you once again back here next time.